So this is a very simple part. It's just a triangular prism. But when you try to 3D print it, or more importantly, print it at scale, there's a number of challenges around these three corners that we're going to show you a solution for today. So this type of part is a very simple part. This is a very simple example that we're going to use. But we're looking at these sharp corners. Sharp corners, when put down on the very first layer, are not something that's desirable. They cause dragging, where the nozzle will reach out to a point and then drag the corner back with it, which will cause a little bit of a warp. Or if you're creating a very dense part, if you were to print this totally solid, with certain high warp materials, then these corners break up from the bed and you start to have a little bit of curling, which is also not desirable. And it's an error that can come up a lot, especially in mass production of a part like this, so we want to address it. Also, there's a lot of more complicated types of designs out there than this simple triangle. There's things like the shark, where there's a lot of sharp pointed edges, or something maybe like a tree design, or even something as simple as a gear, where warping at corners can be an issue. Now, the traditional type of solution to help with warping is to put a brim on this, where you have a single strip all the way around the outer side of the part. And that's fine, but it doesn't always work, and it adds a lot of post-processing because that brim has to be removed from the entire exterior of the part, when really the only thing we care about are these corners. So the other problem is also that the brim is a print setting, and you want the design to not be dependent upon the printer settings or the printer tuning itself. A good design can be manufactured basically with any printer at any time and at any scale. So how can we change the CAD of this so that it doesn't need a software generated brim? Well, the most common solution is actually called mouse ears. And mouse ears are these very simple circles that you place at very jagged corners, which round out the outline of the part so that it doesn't have the drag feature, and create a very high surface area for adhesion right here so that that corner is held against the bed very well. The way you design them is you can place them on the corner, and then you make them as thick as whatever the first layer would be. Generally 0.2 is a very good thickness for these types of features so that the software can catch them. And most softwares will catch them very reliably. This way, instead of having a brim all the way around that needs to be cleaned off, you have just a small area that can be trimmed off very quickly. But this can be optimized even more. This still has quite a bit of touch and can leave residue on that tip. So there's an evolution to this that can be utilized, which is to actually put kind of a sprue off the end of the corner. This way, instead of having to trim that edge and trim that edge, you instead just literally snip off the tip of this mouse ear and it holds it to the corner. However, this one has been exaggerated in order to show that sprue. This is a little bit far spaced and a little bit long, because what would happen is if this part was very dense and had a lot of warping or a lot of internal stresses, it would start to pull up on this little sprue, and it would kind of stretch it and it would still potentially warp. So you want to make sure that this surface area of the disc is as close to the corner as possible. So what we'll do is we'll go in here and we'll edit this sketch, and you'll basically move it in right to the edge. And that is a very good sprue, where you have a very tight control of the part, but again, it snips off in a half a second, so you can produce thousands of these inside of large print farms and not have to worry about a bunch of post-processing, labor cost, or additional cost. So that helps a huge amount with the part, because 3D printed parts are really just the cost of the machine time and the material, but then a lot more cost comes in with post-processing. So rather than using software-generated brims or these kind of basic designs of the mouse ears, you can create these sprue-designed mouse ears which will hold together jagged corners that have a high potential to warp or to fail in the first layer, and they add very minimal extra post-processing to the part. Let us know if there's other sorts of design features that you'd like to take a look at. Comment down below, and please subscribe to the channel so that we can keep on making great content like this. Have a great day, everybody.